Hello and welcome. So given the two matrices below, determine if they are inverses of each other. Alright, well how do you determine if something is an inverse of the other in matrices? Is kind of like how you get what we call back to the identity matrix. So, or the identity element within the particular system. So for example, you guys are already familiar with this idea. Is if we wanted to, with any random Joe number, right, if we want to find the inverse of 2, that's actually 1/2 because it gets you back to 1. And when we call this the identity, where if you multiply 1 by any number, it's going to return that number back. So the identity for a matrix is what we call the identity matrix for 2 by 2s. That is essentially having ones along your main diagonal and zeros everywhere else. Okay, if you have a 3 by 3 matrix, it'll be 1 along the main diagonal and 0 everywhere else, right? If you have a 4 by 4 matrix, the identity matrix will be 1s along that main diagonal, right? Zeros everywhere else, right? And you can keep going with larger and larger square matrices, right? So that is your identity matrix for matrices. So if we're looking at this one, we only have a 2 by 2 matrices. So our goal is that if we multiply these two matrices together, right? If we multiply 2 and 1/2, they get you back to 1, right? If we multiply C and F together, we should get our identity matrix if they are inverses. Now, because matrices are not commutative, meaning that if we multiply C times F, that may not be the same thing as F times C. So we have to make sure that we get this matrix, this identity matrix, both directions through the multiplication. If one way fails, right, if it fails at least once, it's not going to be the identity matrix. Okay, and you know that they're not inverses right then and there. So let's dive right into it. So this first one, we have C times F. So our matrix C, copy that down below, times our matrix F. Okay, and then we'll have to go the other direction as well, so we're going to do F times C in the other one. Now I'm going to go a little quickly through this. I'm going to assume that you guys know matrix multiplication, and then we'll just kind of go through the numbers a little bit. So as we do C times F, and then we'll do F times C. Okay, so this first one, first row, first column, we have 0 times 1, negative 7/8, so that's 0, and then plus 1. Okay, second column, we get 0 plus 0, so it'll end up just being 0. And then we go to our next row, so second row, first column, we end up with, negative 2 times negative 7/8, that'll be 14 eighths minus 7 fourths. And then our next one is going to be positive 1 plus 0. Okay, so we have this one. I'm going to get a common denominator really quick. So we have 14 eighths minus 14 over 8, which is 0. Yahoo! Okay, so then we have, when we combine all that together, 1, 0, 0, 1. Is that our identity matrix? Yeah, right? That matches our identity. We're good to go. C times F is our identity matrix. And that's all it's asking is what is the product right here. So then you would just put that identity matrix in as your answer. Then we'd go the same thing, but then we go the other direction. So then we'd say, all right, so first row, first column. So that'd be 0, and then negative 1/2 times negative 2 is 1, so 0 plus 1. Okay, then we go to the second column. So then that would be negative 24 eighths plus 7 halves is that one. And then we would continue on. Second row, first column, so that'd be 0 plus 0. And then on to the next column, that'd be 1/4 times 4, which is just 1, and then plus 0. Okay, I'm going to get another common denominator, 4 and 4. So then we end up with a negative 20. Hold on, did I say negative 24? That's so awkward. That's 7 times 4. Hello, that's 28. I'm looking at this and I'm like, That just narrowly misses 0. No, it doesn't. Okay, so then we get negative 28 eighths plus 28 eighths, which is 0. Huzzah! So we get 1, 0, 0, and 1, which again is the identity matrix. So that is our product for F to C. And because they are both the identity matrix, when you go one way and the other way, we both get the identity matrix. That means that they are, yes, true inverses of each other. Right? So you might be asking the question, what if? Right? What if that wasn't a 1 right there? What if instead we had gotten something like 3? Would that still be a case of them being inverses? Because it passed one direction. What about the other way? No. It has to be the identity matrix 1, 0, 0, 1, right? Has to be that identity matrix, both directions. And if there's at least one number that's off, if it's not 0 or not 1 where it needs to be, it's not an inverse. Okay, so be very careful. If you get the identity matrix both directions, they are inverses. If there's at least one number off, and it doesn't matter which direction you multiply it, whether it's C to F or F to C, you automatically know that they are not inverses to each other. Okay, so be very careful as you're going through these, but it's just saying what's the product, and then that's how you know whether they're inverses or not. Thanks for watching.